All right, so go ahead and put your name on it before you forget. And it's telling you it's law of cosines. But remember, you can switch to law of sines after you find what? The largest angle. And make sure it is the largest angle, because if you switch too soon, you might get lucky and it works out fine, or you might do some things wrong. You also are going to get to a point where it's not going to tell you. That's what we're going to do tomorrow. They're going to be mixed up, and then you're going to have to decide. I think on the front, well, clearly that's just like what I gave you yesterday. But then on this one, you're going to have to label some things and find some things maybe that it didn't ask you for to find something it did ask you for, that sort of thing. And then, you know, you use variables you want to use. You can use X and Y, whatever, if you want, as long as you know what goes with what angle. I think you'll be okay on this side. It's back here where it starts talking about finding the length of the median. Okay? What's a median in a triangle? Any ideas? What does median mean? The middle, okay? So the median is the middle. If I draw a triangle, okay, it says find the length of the median from A in triangle ABC. So if I make this A, B, C, right? So the median median means middle, but the median of a triangle would be like what kind of figure? Would it be a point, a circle, a line segment? Like what would the median itself be? A line, or a line segment, right? So we can find a length. So it's a line segment, and it means middle, right? And it says from A. So I'm going to go from A to where do you think? To BC. Where on BC? The middle, because that's what median means, right? You see how you can reason through it even when you're not sure? Like what would be a logical guess? So the middle of BC would be like the midpoint, right? Which means these two pieces are the same, and so my line segment would be right there. Now, could I have made this A and then it come down here, or this A? And yeah, it doesn't really matter because you don't really know necessarily what the angles and stuff are supposed to be. But then you can go through and you can label things, right? Okay. So then it talks about a parallelogram has a 70-degree angle and sides of 6 centimeters and 10 centimeters long. All right, so let's talk about what we know about a parallelogram. So here's my parallelogram. Doesn't even have it named, so that's okay. And this is 70. And then the sides are 6 centimeters and 10 centimeters long. Do you necessarily know which is which? No. Do you think it really, really matters? No, it really doesn't. So we'll do 6 centimeters. 10 centimeters. Okay. All right, so what do we know about parallelograms? Opposite sides are parallel. That's what makes it a parallelogram, right? So these are parallel, and these are parallel. Zeke, did you say something different? Good. All four of these add up to give me 360. Okay, these two add up to 180. Y'all agree with that? Okay. What's true about these two? They're congruent. Okay, so in a parallelogram, your opposite angles are congruent. Your consecutive angles are supplementary. And the reason that your consecutive angles are supplementary is that these are parallel lines cut by a transversal, and those are same side interior angles. Okay, so that's how you know that for sure. So if this is 70, what is this one? 110. And what's this one? 110. And this one is 70. Okay, what's the length of this side? 10. And what's the length of this side? 6. Okay. And so what it asks me for are how long are the diagonals? Are the diagonals congruent? What do you think? If you're not sure about things, draw yourself a little example and draw yourself like a drastic example. So couldn't a parallelogram look like this? Like that. So think about that line segment and that line segment. Are they going to be the same? No. And it could be a tall, skinny. I mean, depending on how it's going, you know, it squishes one and makes another one longer. When these are congruent is when you have a rectangle. Okay, so a rectangle or a square, when it squares it up, then your diagonals are congruent. So in a parallelogram, your diagonals are not congruent. That means I've got to do this twice. Okay, I can do this diagonal right here, and when I draw in this diagonal, you see how I made it into a triangle? And do you have enough information to find that diagonal? Yes. And then you can draw in the other one. You might want to like redraw another picture without labeling absolutely everything, but draw the other one in, and then you have enough information to find it that way. Does that make sense to you? Okay. All right, so then we have an isosceles trapezoid. What makes a trapezoid a trapezoid? Yes, the bases are parallel. It's exactly one pair of opposite sides parallel. Right? So then what makes a trapezoid an isosceles trapezoid? The legs are congruent. It's like an isosceles triangle with its head chopped off, right? Okay, so here's my trapezoid. So it's not really looking totally isosceles, but that's the beauty about labeling things. I can do this and then we're good. So then that makes it a trapezoid, an isosceles trapezoid. So this says you have the height of 4 centimeters and a base of 3 centimeters and 7 centimeters long. How long are its diagonals? So tell me about the diagonals of an isosceles trapezoid. Yeah, you think they're congruent? Would it make sense for them to be congruent? They're congruent. So although it says its diagonals, they're the same, so you really only have to find one. What do you know? Okay, so it says the bases are 3 and 7. I'm pretty sure that y'all can label those, right? And then what do you know about what's always true about the height of anything? How do you draw it in something? Perpendicular. I mean, dotted line helps so you're not confused, but it's always perpendicular. Whether it's 2-dimensional or 3-dimensional, the height is always a perpendicular distance. So I like the Leaning Tower of Pisa. It's not how long the building is. The height is the perpendicular distance to the ground. So this is 4 centimeters. And so then you're still going to have to think through a little bit how you can find what you need to get what you need. But I think that just wanted to make sure you remembered some things. And then this, you just know how to draw in the diagonals. Okay. We good on that? So that's if you know that geometry stuff, you can get through the rest of it. It's a matter of just working through the problems. Okay. So you have the class time to just work through it and then ask me questions if you have questions. I've got them all worked out so I can. Oh, I did want to change one thing on here though. The directions say solve each triangle for the missing parts, round angle measures to the nearest degree, and the links to 3 decimal places. I decided I just want you to round everything to 3 decimal places. I just think that's better. Everything to 3 decimal places. And make sure that you pay attention to your units, because one of the things that I noticed sometimes with some of these is that you find a number, but you're not sure, like you put degrees on it, but it was a side length. So that tells me you don't really have any idea what's going on. If there are no units like 1, 2, and 3 for the side lengths, it's fine. You make sure you put degrees on the angles, but if the sides, if they're not given units, it's okay to leave them off. On the back, you're given units, so make sure you use them for the ones you have. Okay, we good? All right, so make good use of this time and work so that you can get it done and ask me questions. Okay?